Good morning, class. So, in this video, we're going to cover some basic laws of algebra so you can get comfortable with some of the math terms that we're going to be using as we solve our physics equations. So we're going to start over here with identity laws. So the purpose of these laws is to simplify equations when we're using the two simplest numbers to work with, 1 and 0. The first one, a plus 0 equals a. So any number adding 0 to it is still just that number. If I have 2 and I add nothing to it, I still have 2. Our second identity law is a times 1 equals a. Anything times 1 is that thing. The reason for that is when we multiply, what we're basically saying is I want to take this many groups that each contain this many things. Simple? Simple. So the next one is a times 0 equals 0. Anything times 0 is going to be 0. The reason for that is, again, when we're multiplying things, we're saying I want to take this many groups that each contain this many things. When we have 0 for our initial velocity, when we start from rest, if I drop this piece of chalk, it starts from rest. I would put in 0 for my initial velocity. Well, 0 times anything is 0. So if I had, let's just rewrite this part. So we'll plug in 0 for VI. 0 times t is still going to be 0. And so I would still have 1/2 at squared. And then I have 0 plus 1/2 at squared. Remember, anything plus 0 is that thing. So I would have 0 plus 1/2 at squared. I'd be left with 1/2 at squared. Simple enough, right? So logically, it follows that if I have an equation that looks like a times b, so a times b is equal to 0, well, I know the way to get 0 is to multiply something by 0. So one of these has to be 0. So after that, we have the same identities, but they're in division form. So a divided by 1 is going to be a. Because what I'm ultimately saying is I have a total of this many things, and I want to divide it into this many groups. So if I have 20 pieces of chalk, and I want to divide it into one group, well, then I'm going to have one group of 20 pieces of chalk. And then a divided by 0 is going to be 0. So you're going to want to be careful with that, because sometimes we're going to end up with a 0 over here that's going to look like it could be divided through. But if we divide it through, then we're going to cause everything to go to 0. And we don't want to do that. Okay? Next, let's get into our algebra rules. So I'm just starting with some basic ones here, and I've got a few of them here. You can't see it, I'll be saying them, so go ahead and take some notes while I'm talking, and that'll help you get used to these. So our first rule is going to be a over c plus b over c is going to be equal to a plus b over c. Now, when we talk about algebra rules, we're really saying this is the way that the numbers logically work. So if I plug in numbers to these, it will make sense. So let's just say I'm going to put 2, 3, and 4. Now I don't want to use zeros or ones because that's going to cause my identity laws to screw with this logic. And then my ratios aren't going to be as true. So 2 over 4 plus 3 over 4, substituting these in. So my a is 2, my b is 3, my c is 4. It should equal 2 plus 3 over 4. So what I'm saying is I've got 2 fourths plus 3 fourths is equal to 2 plus 3 fourths. Well, if we think about that, let's say we're working with inches. That's nice. We work with quarter inches a lot when we're measuring things. So 2 over 4, that's 0.5 inches. plus 3 over 4, that's 0.75 inches. So that should equal, well, what's 0.75 plus 0.5? That should be 1.25, right? Well, then 2 plus 3, that's going to be 5 over 4, and that's also going to equal 1.25. So they make sense. So whenever you're trying to figure out, does the algebra work? Does this actually work? While you're trying to figure out problems, you can always just ignore the numbers you already have from the problem and substitute in your own. I almost always do this when I'm trying something that I'm not sure really works. I'll just say, okay, 2, 3, 4, 5, go. Okay, so the next one is going to be a times in parentheses. So remember, we always want it, if we remember our order of operations, we're going to do everything in parentheses before we do any multiplication or division. So inside these parentheses, we have b plus c. So we're going to do b plus c first, and then multiply that result by a. Well, the logic actually works that a times b plus c in parentheses is the same thing as ab plus ac. Does that make sense? So, again, let's substitute in some numbers. So, 2, 3 plus 4 should equal 2 times 3 plus 2 times 4. Order of operations says the thing in parentheses gets done first. 3 plus 4 is 7. So 2 times 7 is 14. And then over here, it should equal the same thing. So 2 times 3, that's 6. Plus 2 times 4, that's 8. And 8 plus 6 is 14. So that holds true. So we can, remember, we can always substitute those numbers in. So our next basic rule of algebra is going to be the fact that a times b over c is equal to ab over c. Now this is actually one we're going to see pretty often, so pay attention. To think about this the right way, you've got to think back to the order of operations. We're going to do parentheses, followed by exponents, multiplication, division, addition, and subtraction. PEMDAS. So it doesn't actually matter the order we do these two in. Multiplication or division, they're interchangeable. So if I have this kind of setup, a b over c equals ab over c, what this is ultimately saying is that because multiplication is grouping things together and division is dividing things into groups, it doesn't really matter what order I do them in, because all of my grouping and ungrouping is going to result in the same value regardless. Does that make sense? So if we substitute in some real values here, we have 2 times 3 over 4 equal to 2 times 3 over 4. So 3 over 4, that's 0.75, times 2, that would be 1.5. Simple enough. 2 times 3, well, 2 times 3 is 6 over 2, over 4. And if I simplify that, then I've got 3 over 2, which is the same thing as 1.5. So it works. So where are we going to see that? Well, we're actually going to see that whenever we're trying to rearrange our equations, especially our acceleration equation, because we're going to end up moving single variables around, and we're going to need to be able to merge them together on top. Okay? So our next basic law of algebra is actually going to come up a lot when we're converting between units. So like when we're trying to go from meters per second to miles per hour, or more commonly, the other direction, because we want to get into metric more often than not. So what we're going to look at here is a over b divided by c over d is equal to a over b times d over c. Notice that c over d turned into d over c. We flipped it. So this is called cross-multiplying. So whenever we're dividing fractions, we can cross-multiply them instead. And actually, it simplifies things, and it still results in the same thing. What this is called when you flip that is a reciprocal. So A over B divided by C over D is equal to A over B times D over C. So let's substitute in some real numbers. So we're going to use 2, 3, 4, 5. So 2, we'll do 3, 4, and 5. I'm not going to be able to do that one in my head. So 2, 4, 3, 5. So I'm going to use a calculator. 0.5 divided by 0.6 should be equal to 0.5 times, sorry, that should be 5 over 3. 1.6. We'll say 1.67, rounding. So 0.5 divided by 0.6 equal to 0.83 repeating. That should be equal to 0.835. Now that slight discrepancy is due to my rounding here, because this was 6 repeating, and I just rounded it to 0.67. All right, so the last basic law of algebra that we're going to cover in this video is the fact that A over B over C is equal to A over B times C. Now the reason for that is, again, the grouping and ungrouping of multiplying and dividing. If I say I have A many things, and I want to divide that into B many groups, and then once I have that, I want to divide it into another C many more groups. Well, I could just go B times C and have that many groups to begin with, and then divide A by that many. Now that might sound a little complex, so let's go ahead and plug some numbers in to make sense of this. So we'll use our classic 2 over 3 over 4 should equal 2 over 3 times 4. Now this is another one I can't do in my head. Handy calculator. 2 divided by 3 is equal to 0.6 divided by 4 is equal to 0.16. Repeating. So that should be the same as 2 over 3 times 4. Drum roll, please. 3 times 4 is 12. 2 divided by 12, oh gosh, is 0.167. Right on the money. So that last one is actually kind of important. It really comes into play when we're working with our units. If you haven't noticed, we're working with meters, seconds, meters per second, and meters per second squared. Now, where does that meters per second squared come from? Well, first, our velocity, remember, is measured in meters per second, which is our displacement over time. Now, I know that's a little confusing, so I'm going to erase that, and I'm going to put an X there. It can really mean the same thing. So X over time, so meters over seconds, that's where we get our units from. Simple, right? This is the basic math of it. When we multiply and divide units, they actually merge together. And that's going to play an important role later on when we're working with things like joules and newtons. But you don't have to worry about that for now. So acceleration, remember, is a change in velocity over time. And whenever we're working with mathematics, and we want to say a change in something, we actually want to denote that little triangle. And this is a Greek letter called delta. So delta V means the change of V. Now we're not going to work too much with that, but that's just a fun little tip to know. So V over T, well, that's meters over seconds for V over seconds. Well, by this last law that we looked at, meters over seconds is the same as meters over seconds times seconds. Seconds times seconds, quite a mouthful, is the same as second squared. So that's where we get our units from. Make sense? Great. If you have any questions, let me know in class. Thanks, guys.